So question 4, graph the piecewise function on the axis provided. So when I put negative 10 in for x, negative 10 plus 6 is negative 4. But the absolute value of negative 4 is 4. Then we have the negative in front, which is kind of ironic. So negative 4 plus 4 is actually 0. So that one's written a little bit tricky just to get us back to 0, right? When we try the next point, we've got negative 3. So negative 3 plus 6 is positive 3. Then we take the absolute value of the 3, we get 3, but then we have to negate it. So 4 minus that 3 is 1. So that's our first ordered pair. Well, our first set for this function. Now we go to the second function. Negative 3 squared is 9, minus 8 is 1. Positive 3 squared is also 9, and minus 8 is still 1. And finally, for the last function, when we put the 3 in, 3 minus 5 is negative 2. Absolute value of negative 2 is 2, but I have the negative in front, so 3 minus that 2 is 1. And 10 minus 5 is 5. And the absolute value of 5 is 5, but I have the negative, so it becomes negative 5. 3 minus 5, or negative 5 plus 3, is negative 2. So the only problem is we have two absolute value functions and a quadratic. So I can go down and plot these points. What I can't do is just connect dots because these are not linear functions. So let's go through and plot the points we know. So the first thing we have is negative 10, 0, negative 3, 1. So I'll grab my plotting tool. I go to negative 10, and I stay right here on the x-axis because y is 0. And then I go to negative 3, and I go up here to 1. So I know these are the endpoints, though that's my domain is in here. I can't just connect those 2 points because this is not a line. So now this is the endpoint of my first function and the start of my second function. So I don't need this point, but I do need the next one, which is positive 3, 1. So I'll go and make another dot at positive 3, 1. So I know between here and here is another function, but I can't just connect the dots. So we're going to graph that in just a minute. And finally, for the last one, I know my first point is positive 3, 1. My last point to finish off is actually 10, negative 2. So those are the key points that I need to graph this function. So now I'm going to go to a Desmos calculator and plot this function on a graphing calculator. So notice when I put our 3 functions into the graphing calculator, our first function is this absolute value function, going all the way over to negative 10. Our second function is this quadratic coming down. And our last function is this absolute value again. So if I take the key points and record them, those are the points that I can plot to really make a good absolute value function. So now, taking note of these points, if I translate those points to my piecewise function, I can graph it. And remember, you see the parabola from negative 3 to positive 3. So these x lines in the middle will not be part of our function because from negative 3 to positive 3, it's a parabola. Okay, so the easy part, once we have these points, is we can just connect the dots for the absolute value part. So definitely writing on a screen, an absolute value function is far easier to record than a parabola. All I needed was the vertex. Now the trickier part is when we create the parabola, we want a nice smooth curve. So sometimes what I'll do is actually start and make the dip at the bottom first. And I didn't record the process of building that whole thing because I figured that was just enough torture for one day. So this is what your picture should look like, and you can steal my picture if you need, but to show me that you did the work, I want you to create the absolute value function below and include your domains for X. Thanks, everybody. Have a great day.